w- we at my lab and the Lemon Center, together with the Lemon Foundation, we are doing a project in Sobral, and the idea is to revamp science, STEM teaching in the city of Sobral. So, as you know, Sobral is a very kind of famous city in terms of education in Brazil because it has the highest scores on IDEB, which is like this national test, and national kind of ranking of schools, as you know. And in some cases, if I'm not, I think it has like it's 9.8 or something. It's almost like a perfect score in in IDEB, and it's the highest in Brazil. And people talk a lot about Sobral because it's a city in the, in Ceará. It's not like in one of the richest states it's not like in São Paulo or Minas Gerais. It's in Ceará, which is in the northeast of Brazil. It's a remote city. It's not like even Fortaleza, which is the capital. So people keep wondering, like, what's the secret of Sobral, right? And I'll talk a little bit about that. But one thing we realized is that if you just look at the scores and the kind of IDEB and all of that, it seems like everything is perfect and everything works and all of that. But when we go there and we look at what teachers are doing and how the system works and all of that, we realize that there is a lot of space for improvement. So one problem that we have some economists in the room that when you have a successful model that gives you a very high ranking, there is a huge incentive to just keep doing the same because you don't want to lose what you already achieved. Right? And I think that's one of the problems in Sobral is that they achieve very high position in the rankings, but is that the way forward, right? I mean, the way that was achieved was by standardizing a lot of the contents, standardizing. There is some teaching to the test that's going on, and so that works for the set of incentives that exist in Brazil right now. But is that going to work for more challenging incentives, or is that going to work for science, for example? Because there's no national test for science, right? So how do you take the system of Sobral that is very driven by kind of catering to national rankings and exams, and how do you make the system improve in an area, in a kind of discipline that is not nationally tested, right? Would people care at all? So those are very interesting questions for me, and I think very important for Brazil too, because mostly Portuguese and math are the disciplines that people focus on because they are nationally tested. But there are lots of other things like history, science, geography, social studies, and all of that. And those disciplines are not nationally tested. So how do you get the system to focus on those two? Anyways, so that's a bit talk about is this a model for Brazil? And so the context of Sobral is related to that, and also a very interesting thing there is that it's a city that the Secretary of Education, the students, the teachers, everybody is very proud of education, of their achievements in education, and it's a really the team is very excited. They really want to work hard to improve the education in the city and all of that. And it's a pretty different, from my experience, a pretty different context from other cities where people in secretaries of education are demotivated, are kind of hopeless and all of that. So anyways, what we want to do in Sobral, and then I'll go back to it next week, there are three parts. One is develop a new science standards, and a new science curriculum based on kind of the international state of the art. Unfortunately, the new BASI is not state of the art, but we hope that we can improve it in Sobral. So that's part one. Part two is to implement a new kind of science and technology lab, like you can call it like a fab lab or a makerspace and all of that. So have those labs in every school in Sobral to achieve those three goals. First, practice science and technology as a way to develop 21st century skills. Have technology as a way to apply the knowledge of science. So when you're learning science, you can apply that knowledge in technological projects, in inventions, in things you create in the lab. So science is not just theoretical, but it's something you use to build and create stuff. And also allow learning that's more based on constructivist and constructionist theories, which is you can more popularly call it like hands-on learning and things like that. So that's goal number two, and then goal number three is teacher training, professional development. So the idea is this, to build a kind of holistic project that has a curriculum, teacher training, and a new context to do the teaching and learning of science. So this new physical spaces. So what is the state of the art in curriculum design and national standards around the world? So those are the 5 things that people are doing all over the world that we want to bring to Sobral. And I'll go back to it next week, but in very, I realize that the slides are in Portuguese, but I guess everybody, except you. You speak Portuguese. Oh, you speak, okay, sorry. I was like, this kind of cognitive, I was talking, so you can. Anyway, so very quickly, first principle is to focus and structure the standards around big kind of generative ideas instead of like, a ton of little ideas. So ideas like energy, climate, things that are, you can say, like on this year we'll focus on 3 big ideas. So that's what people do around the world. This idea of progression. So you learn something in 1st grade and you go back to it in 3rd grade in a more complex level than in 5th grade and all of that. So those kind of spiral progressions. Going deep, even if you learn less topics. So for example, in many places, many countries, people got rid of topics in science, for example, optics, because they realize, well, it's better to learn deeply a few topics than, it's learn like everything superficially. So that's another trend, is to reduce the number of topics but dedicate more time to them. This idea of hands-on, heads-in methodologies that some people call active learning, some people call, hands-on learning. There are all kinds of names for that. And then finally, the idea that science and engineering or technology should be taught together. So in the next generation science standards in the US, for example, there are topics of, like engineering is a mandatory topic. So kids have to create prototypes, create inventions, analyze solutions, look at problems, design solutions for problems and all of that. So, robotics, for example, or those kinds of things. In the US now they're part of the national standards, and in other places like in Canada or the UK and all of that. So they're not optional things anymore. So those are the 5 things that we want to incorporate into the curriculum. And then, so I would just quickly talk about the strategy. I was talking about before, how do you make a system pay attention to something that's not nationally tested? So one is that this idea of maker spaces, of fab labs and all of that, that's something that every Secretary of Education wants. So that's sort of a Trojan horse kind of thing. So that's a way to make people pay attention. So if we were just saying we're going to rewrite your curriculum or your standards, people say, yeah, whatever, like we don't care that much. But if we say we're going to renovate the labs, create these maker spaces and all of that, that's something that policymakers care about. So that's part of the thing. But we realized over the years, working in the U.S. and in other places, that the bottleneck is that even if we have a lab, the teachers, they don't have the technical training to use the lab. They are afraid of the lab. They have all kinds of traumatic experiences with math and science and all of that, and they don't have time to go there and redesign their lab and all of that. So one strategy that we developed that we are applying in Sobral to overcome that is to have the lab teacher, and that's like a big deal for us. So when we started this project, we told the Secretary of Education, like, we are only going to engage in this if you commit to hiring an extra teacher for each school that will take care of the lab. Right? And that's sort of another kind of Trojan horse in a way, because that, a big part of the benefit of having a lab is not the lab itself, but it's that now we have an extra teacher in the school that can do all this kind of project-based stuff, all this hands-on thing and all of that. So, thinking of this kind of Trojan horse metaphor, we use the lab as a pretext to make the Secretary of Education hire a lab teacher, train this lab teacher and all of that. And, we have to end, but I'll just say one quick thing is the formula that we have adopted in many places is that, classically, people have tried they build a new science or engineering lab, and then they train all the teachers in the school to use the lab, but then the training is never enough. The teachers are still afraid. They don't go into the lab. They don't have time and all of that. So the formula that we adopted in many places with a lot of success is that when you have this lab teacher, the lab teacher, we get the school to give some hours every week for the lab teacher to sit with the science teacher or the math or the history teacher, and then they take a unit that they teach normally and they redesign it together. So for example, a unit on Newtonian physics, for example. So the physics teacher or the science teacher, they get like 3 hours a week and they sit with the lab teacher and they together redesign the Newtonian physics unit to use the equipment in the lab, or to use project-based learning or hands-on learning or sensors or all kinds of things. And like this, they start redesigning, one by one all the units they teach. I mean, not all of them, but a critical mass of units. And then they become part of the everyday kind of teaching and learning routine of the school. They have these new units. They teach them together with the lab teacher, and then it becomes part of the normal stuff they do at school. So that I'll talk more about that, but that's the formula that we derived from many experiences and that we're using in Sobral. So fortunately, we got the Secretary of Education to hire 2 extra teachers in the 2 pilot schools that we're doing, and I'll show you lots of pictures next time. This is just a sneak peek of kids actually doing a lot of those are the labs, just like kids for the first time in their entire school life doing hands-on experiments and as part of their normal classes. So this is not like an after-school thing. Here they were looking at electrical circuits. Here they're looking at pressure, like gas laws and pressure and all of that. So this is just from the last few weeks, and looking at that's a bottle with a pressure sensor. They're doing experiments and all of that. So, anyways, this is a sneak peek so that you come back next week and we can talk more about the results. So I guess we have like maybe 1 minute if you want to ask questions, but it's a pretty exciting thing to see, those kids learning science in this way for the first time in their lives, and the teachers feeling very kind of empowered and happy by being able to do this instead of, I mean, I'll show you next week the way they used to teach science was to get in the front of the classroom with the book and basically recite the textbook and write the textbook on the, yeah, yeah, so, yeah, we're working with four schools. Yeah. But anyways, it's, you know, it's pretty cool too. But I'll talk about it more next week. Okay, so if you don't have questions, I think we're out of time, so we'll continue next week. They use Arduino and the Google board, both. Yeah. Cool. Okay. Talk to you soon.